Hi there, in the screencast I'm going to give you kind of a quick sample of the screencast that you need to be producing. Okay, so here we're looking at two functions, polynomial functions, and we can tell a lot about their graphs simply based on looking at their equations. So the first thing we want to find out about is the end behavior. In other words, does the graph start down and end up, or start up and end down, or start down and end down? This is identified by the degree of the function and the sign of its leading coefficient. So for f of x, you can see that we have a positive leading coefficient, and the degree of the function, which is the sum of its exponents, adds up to 5. So that's positive and an odd function. Positive and odd function means that the graph is going to start down and end up, which it does. The next thing we can tell is where the graph will intersect the x-axis. Those are the zeros of the function, and based on the factors for the function, we can tell that that is going to be -3 and +2 for this function. And sure enough, the graph does touch or cross the x-axis at these points. And finally, when the graph intersects the x-axis, we can tell by looking at the individual factors whether the graph is going to cross over and go through the x-axis or do a turnaround right on the x-axis. So since -3 has an odd exponent, we know that the graph is going to go straight through the x-axis when it intersects it. Since x minus 2 has an even exponent, we know that the graph is going to turn around right when it goes through the x-axis. If you look at g of x, you'll see that the only difference is there's a negative coefficient, which affects the end behavior. Everything else would be identical.